Hello, I welcome you all in this presentation related with the subject fundamentals of surface engineering, and we are talking about the methods wherein a layer of the good quality material is applied on the surface of the substrate so that the required change in mechanical properties and tribological properties can be realized. Now in this presentation basically we will see the different surface modification processes which are related with the weld surfacing. So basically it is about the weld surfacing processes, and we will be starting this presentation with the different materials which are used, material forms which are used for surfacing by developing a layer of the required quality of the material. So materials can be used in variety of forms. For example, so here in the first column we have form. Form may be in form of solution, like the elements to be deposited in form of layer are used in form of solutions, and this is primarily used in a process which is called like electroless process, and it is used for depositing the depositing layer of like say the nickel or the nickel phosphorus kind of the compounds. It can be used for depositing the coatings of such kind of materials on both conducting and non-electrical conducting materials. So it is not necessary that the workpiece material has to be electrical conducting. It can be used for depositing the coatings of the required material onto both the conducting and non-conducting kind of the materials. Then we have the another form of the material which is like in powder form. The material which is to be applied is available in powder form. It can be like the nickel or chromium or aluminum or any other suitable material like alumina, silicon carbide, etc. Whatever we have to deposit, apply on to the substrate, that is available in powder form, and it is used with the like say it can be used with the laser or electron beam or plasma arc welding process. It can also be used in case of the thermal spray processes like oxy-fuel spray process or HVOF or detonation gun kind of processes. Then this is very widely used for depositing the like the layer of the required metal in form of like say austenitic stainless steel, martensitic stainless steel, or application of the the aluminum layer. It at the same time it is also used for developing the layer of composites. For example, nickel tungsten carbide, nickel chromium carbide, and nickel boron carbide kind of the means composite layers can also be developed using these processes wherein the material to be applied on the substrate is in form of powder. Then it can be in form of the strips, like thin strips, and this is particularly used in case of the submerged arc welding process, especially when it can be used like ferrous metals or steels, especially when the large surface area is to be covered. So if a very wide area of the surface is to be modified, then material in form of strips is used in case of the submerged arc welding process. Then we can use wires. wires of the different diameters like 1.6 to 2.5 like that, and it can be used in the processes like non-consumable as well as consumable processes. For example, gas tungsten arc welding, gas metal arc welding, or plasma arc welding process. So, at the heat source like arc, the wire is fed for fusion and getting it mixed with the fused base metal to form a bead-on plate. So, this can be used for developing the claddings and coatings of nickel or austenitic stainless steel or ferrous metals, different category of ferrous metals like high carbon steels, and other layers also can be deposited as per the requirement of the surface modification. Then one more form is there, which is like electrode, where metallic wire covered with the coatings so this is like when the coating is applied outside of the electrode. This is typically used in case of the shielded metal arc welding process, but there can be another variant where the metal in form of the tube is filled with the flux. So, for the flux with the presence of the flux, which will help to provide which will be providing the required protection as well as the formation of the slag. And apart from that, it can also be used, the fluxes can be mixed with the required constituents like we can add tungsten carbide, chromium carbide powder mixture. So, after getting mixed with the base metal as well as the tube which will be fusing, it will be forming the carbides, or it will also be forming the composite weld surfacing layer, or it will be leading to the modification of the chemical composition of the weld bead which is being developed by incorporating the elements to be introduced with the flux itself. So, electrode can be in the two form, where coating is applied outside or inside. So, this is called like flux cored, or it is also called metal cored electrodes. So, in case of the metal cored electrode, we introduce we fill in, besides the flux, we also include the constituents in form of in the powder form of the elements that we want to introduce, or constituents that we want to introduce, which may be in form of chromium or nickel or any other element that we want to add in the bead-on plate weld, or we can add the suitable constituents in form of carbides, borides, etc., so that they can be incorporated in bead-on plate weld. So, like shielded metal arc welding will be using the electrodes where flux is applied outside, and flux cored arc welding will be using the electrodes where the flux and the other constituents are filled inside the tubular electrode, and this can be used for developing the layers of all ferrous metals or developing the composite layers. So, this is about the description of the various forms in which the material is applied, and where this kind of the methods can be applied, like all those processes where arc is to be established, like in shielded metal arc welding, gas tungsten arc welding, submerged arc welding, flux cored arc welding. In all those cases, it is necessary that workpiece is having the enough electrical and thermal conductivity, so that the arc can be established. While in case of the laser welding, it is not necessary. In case of electron beam welding, it is not necessary that the workpiece is electrical conducting. Now, we will be talking about the way by which the beads are deposited, like this is the substrate, and using the suitable source of the heat is applied onto the surface of substrate. This will be melting the substrate up to certain depth. Now our heat source can itself provide the metal to be applied in case of the consumable arc welding processes, or if the electrode is not providing, like non-consumable arc welding processes in case of say gas tungsten arc welding, plasma arc welding, or our laser or electron beam. In both those cases, in all those cases, the heat source, our source will be providing just heat, and metal to be applied onto the surface of substrate has to be fed from outside. So assuming that this is the heat source and facilitating the melting of the substrate, so either melting of the electrode or the filler itself will be providing, or we have to feed it from outside. So this feeding can be in form of the filler, or it can be in form of the powder. So this heat source will be facilitating the melting of the substrate as well as the melting of the metal to be applied. So the metal to be deposited will be applied in form of filler, strip, or the powder in the zone of the heat source, so that melting of both substrate as well as the material to be applied can be facilitated, and after the development of the weld bead, required surface modification can be achieved. Now this heat source is very important for melting of both substrate as well as the metal to be material to be applied onto the substrate. So heat source, and now the heat can come from the various sources, like it can come in form of the chemical energy through the combustion of fuel, gas, and oxygen mixture. So the fuel gas like propane or acetylene will be mixed with the oxygen, and it will be burned to produce the heat through the exothermic reaction. So that will be providing the heat. There is another source of heat, that is the arc. So suitable arc is established either between the consumable electrode or non-consumable electrode like tungsten, and that source of heat is used. So here either between the electrode, which is consumable or non-consumable, and the workpiece, arc is established. So this will be facilitating the melting of the substrate, as well as if the electrode is consumable, then itself will be consumed, otherwise you have to feed it from outside in the arc zone, so that the melting of the material to be applied can be facilitated. Now depending upon the processes, the different energy densities are observed, like chemical, in case of the chemical energy, where the combustion of the fuel gas and oxygen is used, this approach is used in case of the gas welding, and arc is used as a source of heat in case of like number of processes like shielded metal arc welding, and gas metal arc welding, gas tungsten arc welding, plasma arc welding, flux core arc welding, etc. So in all these cases, arc is established between the electrode and workpiece. So workpiece has to be electrical conducting, and then only the arc can be established. Then there is another source of heat, that is about the radiation energy, where both laser and electron beams are used. Both these provide very high energy density processes ranging up to 10 to the power 8 watt per mm square. So, such high energy density helps to melt the surface layer very quickly and the material which is to be applied. So, the process is fast, it allows good control over the heat input, good control over the quality due to the limited dilution, fast cooling rate, facilitating the fine grained structure. Even in some of the cases amorphous structure is also produced. So, if we see these three processes, because the source of the heat is different, and that is why we get very different heat source having the very different or varying energy densities associated with them. So, as we have talked earlier, if the process is of the high energy density like laser or electron beam, then it will be requiring the less heat for melting purpose, and then it will be leading to the reduced dilution. It will be leading to the increased cooling rate, which in turn leading to the fine grain structure, and so improved mechanical properties, improved tribological properties. So, these are the benefits of the high energy density process, and the reverse happens when we use the low energy density processes like gas welding or shielded metal arc welding, which offer significantly lower energy densities as compared to the high energy density process like laser and electron beam. Further, in between, the energy densities are offered by like GTAW and the plasma arc. So, the quality is also in between. So, the best quality is offered by this kind of process with regard to the dilution and the structure, while the poor quality is offered by the gas welding and shielded metal arc welding processes with regard to the structure, dilution, etc. And so, the performance of the weld surfacing or the surfacing which will be achieved. Now, in general, if we see wherever we use like the shielded metal arc welding or gas welding kind of processes, there we do not have very good control over the heat input and the melting of the substrate, because mostly these are the manual processes. So, the control over heat input is less, and since the heat input is not well controlled, so the dilution and cooling rate both are not controlled properly, and that is why we get the poor quality of the modified surfaces which are developed using the SMA and GMAW process. So, it is very important that heat input and protection is properly achieved for developing the sound weld surfacing, so that good quality modified surfaces can be generated. Now, we will be talking specifically about some of the processes like gas weld surfacing. So, like as the name reflects, in case of the gas weld surfacing, we feed the two different gases like the fuel gas and oxygen, and both are fed and then they are mixed in a chamber. So, fuel gas mixture, both gases are mixed and then they allowed to come out. So, this is where the nozzle of the torch exists. So, the gases will be coming out of this, and here we have to fire it. So, when we fire the fuel gas mixture, we get like a flame having this kind of the cone shape. So, there can be the flame can have the 2 or 3 different cones depending upon the fuel and oxygen gas proportions or gas ratio. The flame structure can have 2 or 3 cones. So, there is one outer cone and there is one inner cone. In outer cone, temperature is low, like around 1200 to 1300 degrees centigrade. Although outer cone is called is the zone where the secondary combustion takes place and increased amount of the heat is generated. So, more heat is generated in the outer cone, while in case of the inner cone the less heat is generated. This is the zone where primary combustion takes place. So, less heat is generated, but if we see the outer cone area, surface area which is exposed to the ambient atmospheric gases, the area is large, and the gases and the atmospheric gases are at low temperature. So, the flame temperature, outside flame temperature is low, that is 1200 to 1300 degrees centigrade, while the inner cone, where despite of having the less heat generation, since its area is less, as well as it is covered around the hot flame of the temperature 1200 to 1300 degrees centigrade. So, the temperature of the inner cone is higher despite of generation of the less heat, and this temperature can vary from 3100 to 3300 degrees centigrade depending upon the pressure of the oxygen and the fuel mixture which is being used. In general, the increase of pressure of the oxygen increases the heat generation and temperature. On the other hand, the increase of the oxygen content also helps to increase the temperature of the inner core. So, the fuel and oxygen gas mixtures, although type of fuel also affects, like acetylene offers the maximum temperature, while other propane and butane kind of the fuel gases offers a lower temperature like 2800 degrees centigrade. So, maximum temperature is significantly affected by the type of fuel gas which is being used. This is one aspect. So, we always expect that there is a approximately equal amount of equal proportion of the both fuel and oxygen gas mixture is used for producing the neutral flame, where whole of the fuel gas is completely burned by the oxygen which is available. If the oxygen is more, then it leads to the production of the oxidizing flame. Oxidizing flame offers the higher temperature as compared to the neutral flame, and if the fuel gas is more as compared to the oxygen, then incomplete combustion leads to the development of the carburizing flame. Now, important is here that here it will be having excess oxygen and here it will be having the excess of the means unburned fuel. Which is basically hydrocarbons. So, carburizing flame transfers the carbon to the weld pool or weld surfacing, while oxidizing flames may tend to cause the oxidation of the allying elements in the molten pool, and so there can be possibility for the oxides as well as loss of allying elements. So, it is always preferred that we use the neutral flame, otherwise carburizing flame will tend to modify the chemical composition of the bead which is being deposited through the carburizing flame, and this compositional modification primarily happens in terms of the increase of the carbon content. So, like say if this is the medium carbon steel which is being modified with the help of the gas flame, and we are feeding the electrode, and a bead, weld bead is being developed like this. So, the composition of this weld bead will be richer in carbon content if we are using carburizing, and we know that increase in carbon content in the steel in general leads to the increased percentage of the perlite or increased percentage of the martensite as per the kind of cooling rate, and both these factors will be increasing the hardness of the weld surfacing as compared to the case when we use the neutral or oxidizing flame. So, carburizing flame leads to the enrichment of the carbon content, which will be increasing the fraction of the perlite, because increasing carbon content will be increasing the perlite under the low cooling rate conditions, and if the cooling rate is high enough to form the martensite transformation, then it will be leading to the formation of somewhat higher carbon martensite. So, this is one of the implications related with the use of carburizing flame. Now, we will see what kind of the metal systems which are deposited using the gas welding processes. So, like the flux cored electrodes and the fillers of nickel or nickel tungsten carbide or other ferrous metals. These can be deposited using the gas welding process. Since the equipment for the gas welding is very simple, very cost effective, so it can be used effectively for the surfacing of the small areas, and the system is very easy, so it can be applied even by the semi skilled workers also. Now, we will see the another surface modification process by the welding, that is called shielded metal arc welding process. Shielded metal arc welding process, basically I will talk about in general structure of the process. It uses one consumable electrode having the metallic core wire. This is core wire made of the metal to be applied for the weld surfacing, and around that we have the flux coating. This flux coating is thermally decomposed by the heat of the arc. So, this is arc zone. When we use the suitable polarity, or like say we use in case of AC, equal amount of heat will be generated, and if we use DC, so when we use the DC, 2/3 of DC with the workpiece is connected to the negative terminal and electrode is connected to the positive terminal. So, less heat on the workpiece side will be leading to the limited melting of the substrate and more melting of the electrode. So, the heat of the like 66% of the heat generation on the electrode side and 33% of the heat generation in the workpiece side. So, more heat generation will be leading to the faster melting of the electrode, as well as this heat will also be used for thermal decomposition of the coatings, which is already there. So, this flux will be providing the inactive gases which will be forming a cover around the arc to protect the molten pool from the contamination by the atmospheric gases, and so the formation of the undesirable inclusions, oxides, nitrates, etc. can be avoided. So, this is the in general structure. So, there is a power source where basically the positive terminal connected to the electrode and negative terminal connected to the workpiece. When the connection of this kind is made, it is called reverse polarity, DCRP, where reverse polarity, or DC electrode positive, where electrode is connected to the positive terminal of the power source. It helps to melt the electrode at a faster rate and limited melting of the substrate, so that the dilution can be controlled in better way. But the problem with this is that electrode is controlled manually, so the heat being applied per unit length is not well controlled, and that is why the dilution at one section may be low, at another section it will may be high, and that is why the shielded metal arc welding process offers somewhat less control over the heat input as well as dilution. and the dilution in this case may be like 10 to 15%. With the proper control of the process it can be reduced, but if the process is less controlled then it will be on the higher side. Now, I will summarize this presentation. In this presentation basically I have talked about the gas welding process and the sealed metal arc welding process, and how these can be used effectively for surface modification, so that the bead on plate welds can be developed for realizing the required set of the properties which can help in improving the surface properties and improve the life of the tribological components. Thank you for your attention.